Hello, my name is Brianna Burnett, and in this lesson we are going to look at mirrors and lenses. So we're going to look at how these different objects can refract light, reflect light, how they produce the image that we see when we look through them. So let's talk first about a plane mirror. So a plane mirror is just like a regular mirror you have hanging in your bathroom, hanging in your bedroom. It has a flat surface. Whenever you look into it, your reflection is right side up. The image is the same size as you, but you'll notice when you look into a mirror that the image is reversed left to right. That means if you raise your right hand, your image in the mirror is raising their left hand because it's a mirror image. So that means it's going to be a reversed image of you. Mirrors also create virtual images. We have two different types of images. We have real images, we have virtual images. In a plane mirror, you see a virtual image, which means an image through which light doesn't travel, okay? A real image is an image where light can actually pass through it. So in this diagram here, there is a picture of a man looking into a plane mirror. The rays, the red rays here, show how light reaches your eyes. The dotted lines show where the light appears to come from. So mirrors kind of fool you because you feel like you're looking through a window at somebody else looking back to you, which is why it's a virtual image. There's not another you in another parallel universe looking back at you through this mirror, okay? So this is where it looks like light is coming from, when in actuality, light is bouncing off of your image. So looking more closely at this, light reflects off of you and then it bounces and hits the mirror. So what's happening in this mirror is light is reflecting off of you and then it strikes the mirror. That light then bounces off of the mirror at an angle that's equal to the angle at which the light hits the mirror. So some of that reflected light will enter your eyes, and that's what you see. And over here, your image appears to be behind the mirror because your brain is assuming that the light rays that enter your eyes travel in a straight line from an object to your eyes. So that's why we call it virtual. It's not real, a real image, a real you standing over here. It's virtual. We also have something that's called a concave mirror. And these are mirrors that are curved inward. So one way that I am able to remember this is a cave is something you can go into in a mountainside. So a concave mirror curves inward. And these guys are a little bit trickier than straight up plane mirrors because they can form real and virtual images depending on where the light's coming together, because in a concave mirror, light is bouncing off of different places at different angles, okay, and creating a focal point somewhere that's not, maybe not expected. So you will find concave mirrors most commonly as headlights and in flashlights. So if you've ever taken a flashlight apart before, you've taken off that head, you've noticed that the part where the light bulb is, there's this little like upside down umbrella where the light is sitting. That is so the light can be better broadcast out there to help you see. So looking more carefully at this diagram here, let's look at this yellow dotted line. Okay, so a straight line drawn outward from the center of the mirror is called the optical axis. So this guy right here is our optical axis. If we can look right here, this is called the focal point, okay? This is where light rays entering the mirror parallel to the optical axis, so that means they're coming straight in, parallel to this optical axis. They're reflected through a single point called the focal point. So whenever these light rays, the red and the blue light rays come in, they aren't going to bounce straight back because of the way the mirror is curved. So what's going to happen is they're going to come in, and then because of how the mirror is curved, they're going to go a different direction. So the focal point is where these lines wind up intersecting and crossing, okay? So that's where the image will be focused, where the light will be focused. the distance between the mirror's surface and the focal point, which is right here, is called the focal length. So from the mirror to where the focal point is, that is your focal length. So let's look at another figure. I know these figures can be tricky to really digest, but what I want you to get from these images, and this will become more apparent and more easily understood whenever you work on the worksheet that is in the document section of this. I want you to know what kind of image is produced in these mirrors and in these lenses, okay? So don't get all hung up if you're not quite sure where the red lines are going. Focus more on what kind of images are produced. So let's look at this. We're looking again at concave mirror. So we're looking at this curved mirror right here at the part that looks like a cave. So if we have an object that is more than one focal length away from a concave mirror, it creates an upside down real image, which means the light can pass through it. So if you'll remember, our focal length is from the mirror to the focal point, okay? Our object that we're focusing on, that we're looking at, is this pencil all the way out here. So because it is more than one focal length away from that mirror, what we get is an upside down real image of the pencil. And as you can tell in this picture, it's going to look smaller, okay? So in a concave mirror, if the object is far away from it, we're going to get an upside down, smaller image, okay? Now, we still have a concave mirror here. If the object is really close to the mirror or less than one focal length away, we are going to get a right side up virtual image, okay, which means the light rays are not going to pass through it. So if we have the object here and it's less than one focal length away, so it's really close to that concave mirror, we are going to see an image of the pencil. So here's our pencil, but looking through this concave mirror, we will see a larger upright image of that pencil, okay? So you might want to write that in your notes. If the object is far away from a concave mirror, the image will be upside down and smaller. If we have an object that is close to the concave mirror, we will have an object that is right side up and larger than the real object. So a convex mirror is the opposite. So concave, you're going in. Convex, it's coming out. So it's like if you have a spoon, okay? If you pick up a spoon and you look at the part where you scoop stuff, that's concave. If you turn it over the other way, the part that is sticking out is going to be your convex. It's going to look like your convex mirror, okay? So a convex mirror curves outwards. All the images in a convex mirror are virtual. They're all right side up and they're smaller than the original object. So this one's a little bit easier. If it's convex, they're all going to be smaller. They're all going to be right side up, okay? Typically, you'll find these kinds of mirrors as security in stores. So if you're in a gas station or in a grocery store and you look up at the ceiling, you might see a convex mirror that allows for the people working there to see more of what's going on throughout the store. You'll also find these on roads. If it's a really curvy or hilly road, you'll see people tack these up on telephone poles. Convex mirrors are also found on the side mirrors in your car. So while they don't look super convex, they help the driver see more of the road, okay? So if you will think about, again, our object, in a convex mirror, if you are looking at the convex mirror here, the object is going to appear smaller and right side up. So if it appears smaller, that means that you can see more through this convex mirror because everything's shrunken and it shows you more. So again, in a convex mirror, the objects appear smaller and right side up. So that was a discussion of mirrors. Let's transfer that to lenses, okay? So a mirror is something that just reflects an image. A lens is where you can see through the object. So we have convex and concave lenses as well. So whenever Light rays pass through a convex lens. The rays are refracted towards each other, which means they are converging together on a single point. So as light comes through this convex lens, so it looks bubbled on both sides, the light rays are redirected, okay? They're refracted to converge on one single point. When light rays pass through a concave lens, so that means on either side we have a dip, okay? We've got caves. When light rays pass through a concave lens, the rays are refracted away from each other. So they're not converging, they are diverging, okay? So looking through a concave lens, they're thinner in the middle and thicker at the edges. They will always form a virtual image that are smaller than the original and right side up. So you might want to put that in your notes. A concave lens always forms images that are smaller than the original and they're right side up. So look at this picture. Here's our object. What we see is a right side up, smaller image, okay? These guys are found in telescopes, they're found in microscopes and eyeglasses, which all make sense because you're trying to see more. You're trying to see something clearer, sharper, and in better focus, okay? So it's going to give you the ability to focus that light to produce a smaller and right side up image. A convex lens, conversely, is thicker in the middle than it is at the edges, and it's used for magnifying glasses and camera lenses. So we're trying to make things much bigger so that we can really see the finer details, okay? So, again, these are used in magnifying glasses and camera lenses. And in lenses, whenever you're looking at a convex lens, this is where, depending on the focal length of the object, you will get different images, okay? So, our regular object is a pencil again. In this image, we're looking at a convex lens, and because the object is close to the lens, it's less than one focal length away, a virtual image is formed, and the image is larger and right side up, okay? So if the object is close to a convex lens, the image will be right side up and larger. If an object is farther away from the lens, more than 2 focal lengths away, the image is a real image, which means light can pass through it, and the image is smaller than the object and upside down. So again, if the object is farther away from the convex lens, the image will be smaller and upside down. So let's review. This is, again, a little bit tricky. It's something that you really have to commit to memory, okay? So if we look at these again, we've got concave and we've got convex. So concave, so let's say this is like a plane, okay? A flat plane, like a plane mirror that you look at in the bathroom. If you are looking at something that is concave, it's bending in and you're looking at this part that forms a cave. If it's convex, you're looking at the part that is sticking out, okay, that creates this bump. And we have that in both mirrors and lenses. So to show you pictures again, concave mirrors, when you're looking at the cave part of it, objects that are far away from the mirror shows an upside down smaller image. Objects that are closer to the concave mirror create objects that are right side up and bigger. In a convex mirror, you're looking at the outward bump of the mirror. You will create an image that is smaller and right side up. In a convex lens, if the object is close to the convex lens, you will get an image that is larger and right side up. And if you are looking at a object that is far away from the lens, you're going to see an image that is smaller and upside down. All right, so looking at a concave lens, the object is going to appear right side up and smaller. So what I suggest you do is keep this open so that you can flip back and forth from slide to slide, print out that document that walks you through this, and practice with the different scenarios, seeing what these lenses will produce when you look through them. That is what is going to help you really sock this to your mind. So I'll let you do that, and I will see you soon.